All right, another day of backyard mathematics. All right, so today we're looking at kernel. So the kernel of a linear transformation are those vectors that get mapped to zero in the image, all right? So they get mapped to zero in the as a part of the range or the receiving end, if you want to say it like that. All right, so take for instance, if you look at the differentiation map, right, on the vector space that is constituted by polynomials with rational coefficients, all right? So under addition and obviously scalar multiplication also. The derivative that result in zero would be the derivative of the constant polynomials, all right? So any polynomial like p of x is equal to 7, p of x equals whatever number, including zero, would derivative of that would be zero. So the kernel would be the linear functions basically, all right? So it would be the linear polynomials, rather, right? Okay, so how does this fit in with middle school? Well, in middle school, you can think of a linear transformation that maps the linear functions to their slopes. So y equals ax plus b. The linear transformation with t of y would just be equal to a, all right? Whatever the slope of that line is. Obviously, we have lines that have zero slopes. These are also the constants, the constant polynomials, right? Function. So those would be the horizontal lines, right? So that would be the kernel. So the kernel in this case would just be a set of horizontal lines, all right? So hopefully this collection helps between linear algebra and middle school math.